All right, so let's start with what we are here for today. Thank you for allowing me to present on evolution of data architectures and building a lakehouse. Yeah. All right, so I'm a developer advocate at Databricks, where I have been helping our customers as well as developer community to build on machine learning and AI use cases. And now I work in the open source community and help our open source projects and development of new integrations, new features, and things like that. So that's about me. In this presentation, I will go through data architectures and then deep dive into the foundation of Lakehouses, how you build it. Data, analytics, and AI have been the center of innovation. And these are the companies who are always at the forefront of innovation, and we learn from them. So we have come very far along. The companies I'm showing here, of course, you all know, they always put innovation at the forefront, and we learn from their use cases, and they are changing the landscapes. So you must have heard Ali's keynote. This is, he talked about data maturity curve. So on the left-hand side of data maturity curve is data warehouses. This is looking in the past. Before, data warehouses were prominent because we had the information age and everybody wanted to make sense out of data. So data warehouses were used over decades and decades. And then on the right-hand side is forward-thinking people. So companies who want to be at the forefront always thinks to the future on the right-hand side of the curve because they want to automate decision making, they want to do prescriptive analytics, they want to do predictive modeling. So that's how this data maturity curve shows where which company is. If you are not thinking in the right-hand side of the curve, you are lacking the innovation. So, and it's not just FANG companies. These are other companies where we have seen massive innovation happening. For example, Goldman Sachs, they are using AI to approve credit cards under 5 minutes. Comcast, they use machine learning and voice recognition for game-changing Emmy Award-winning viewer experience. Amgen, who uses machine learning to predict models as well as predict behaviors of how patients will react to any therapies. Moreover, they are doing groundbreaking cancer treatment, drug development for that using AI. So these are very transformational use cases. And behind all these organizations, they use Lakehouse platform. Lakehouse platform allows them to simplify every single use case, every single data in one single platform so that they can get to that innovation very fast. They can accelerate that pace of innovation. And also because these companies are using multiple clouds, and Lakehouse offers that multi-cloud environment. So in a nutshell, I'm pretty sure you are all bored at this point seeing at this diagram, but yeah, this is gonna be the image for you for so many days. But there are still so many organizations who still struggle with data analytics and AI. And the reason is that we have so much data coming in and we are not at pace of that innovation. 80 to 90% of data is still not being made intelligent out of. According to Fivetran, 60% reported, this was data analyst survey, and 60% reported why the problems are happening. It starts with collecting data. So 60% of them reported data quality being the top challenge. 86% of analysts used stale data. 41% out of it was was more than 2 months old. And 90% regularly had unreliable data sources. So this leads to getting high quality, timely data is hard, but it's also a problem with system architectures. And that's why I want to show you, before Lakehouses, how data and AI was done. Data warehouses, which were formed or built in mid-1980s, they were awesome at performance. They were awesome at getting high quality, high reliability. And a lot of organizations saw huge value out of business intelligence and reporting use cases. However, the format was closed, so only proprietary engines can read the data, preventing ML frameworks from actually making use out of it. They were suboptimal for ML frameworks. And they only supported structured data, they only supported SQL, and they had no support for, limited to no support for data science, machine learning use cases. And also, since the format was in proprietary, it was expensive to scale out. This is what led to data lakes, which is open. It offers great scalability and flexibility, as well as it supports all data types so that you can do machine learning and AI on it. However, data sitting in data lakes doesn't have any kind of transaction guarantees, doesn't have any kind of any schema enforcement. And you will see in data engineering phases, because these things are important. So your data always or often ends up in unreliable data swamps. So again, we are at this curve. What we are seeing is how organizations are resolving the challenges from data warehouses and data lakes is they are actually using two different systems in one infrastructure, and which is not scalable, and that is not very optimal for AI use cases, because now you got two different systems. They don't understand each other's language, so they are not compatible with each other. And you have silos, you have massive quality problems. You want that innovation to happen. You want to ensure that all data is available in one single place. That's the problem with this type of setup. And so we have Lakehouses today. Lakehouse brings best of both worlds, because we have seen amazing features from data warehouses. We have seen amazing features from data lakes. So how Lakehouse is combining them together is it allows you to do structured, unstructured, all those data in the data lakes. So let's look at that. It's based on open source. That's the foundation, because you will see me talking about open formats, open engines. It brings data warehouse reliability, and Delta is the key enabler of that. And since it's based on any cloud storage, you can use any S3 and cloud features with that. So you are bringing flexibility and scalability. All right, so putting that in a nutshell, data warehouses came in about 1980s. We faced challenges, and that's why in 2010s, data lakes came around. Then we faced another set of problems, and we are today at the Lakehouses. It took us 40 years to deliver the promise of data warehouses. History surely repeats, and it often rhymes. So Lakehouses are delivering that promise of data warehouses on data lakes. This is how the Lakehouse architecture looks like. It's directly based on open data lakes. So you can have all your data in one single place, structured, unstructured, file, log files. And then it adds a transaction layer on top. So before I mentioned about reliability and quality, how it brings that is because it has open transactional layer, and that is because of Delta Lake. Delta Lake is the core foundation of Lakehouse. And moreover, the open formats that we see today in the market, they mainly exist because they were all built on top of open engines like Apache Spark, Flink, etc., which are built for performing high data processing on big data at scale. So with that, we have this whole architecture which comes in the form of Lakehouse, and Delta Lake is the key enabler of that. So let's look at how to build a Lakehouse. This diagram that I'm showing is basically end-to-end architecture. On left-hand side, you have different data sources. It can be either Kafka streams, it can be either different IoT sensors sending data through Kafka. You can put that into your S3. And in the middle layer, I'm showing the Medallion architecture of recommended practice in Delta Lake. And the right-hand side is how you can use the layering on top of the architecture for streaming AI and reporting use cases. So Delta Lake allows you to incrementally improve the quality of your data until it is ready for consumption. And it is, you can see bronze, silver, gold. So let me explain that. First, you have data. So because Delta Lake is compatible with other formats, you can use this specific data frame reader. If your data is in CSV, you can convert that. If you already have Parquet, you can convert in-place Parquet, so you don't have to create duplicates of your data. And then explaining about the middle layer, which is three-tiered architecture, you dump all your data into bronze layer. So basically, whatever is coming in, just dump it all in bronze layer. You don't have to have transformations applied to that, because often organizations want to retrieve that data so that any data missed in the downstream applications can be preserved. Then you apply some transformation logic, or let's say if you're working on GDPR or some kind of audit use cases, you don't want everybody to have access to all of the data, including PII, non-PII. So this is where you do filtering, aggregation, and the sophisticated user of this is either data scientists, product managers, that kind of audience. And then lastly, we have goal layer. This is where you can give access to your business partners, business analysts, so that they can just put a Tableau layer or some kind of business intelligence layer on top of it, because they don't need to see what the data munging has been happening. They want to just see like a quick, nice dashboard just to SQL. So those are the three-tiered use cases in architecture. Cool. So let me dive deep into how Delta Lake is able to do the quality and reliability challenges. How does it solve it? So first, we look at the component of the file structure. Delta Lake is made up of two different things. First one is the data files itself. Because Delta Lake uses cloud storage underneath, storage is scalable. And then it adds a transaction layer on top. How does it look in practice is like this. So you can see that on my top, there is a Delta log directory, and then all the other things, other files are Parquet files. So if you're familiar with Parquet files, it's like in parts format. And then let's dive into Delta log directory. Under Delta log directory, you can see that there are a lot of like different versions, and there's checkpoint. So checkpoint is kind of like a hook wherever you have a loss in data, or your network goes down, but your data was already being processed. So it takes like a snapshot at the checkpoint directory. Whenever that case happens, you can always retrieve back. That's why the checkpoint exists there. And anytime you do any commits to your data, for example, one change that you make, Delta makes sure that it takes a snapshot of that in the form of versions. So this is how the Delta log directory looks like. And it has like so many use cases, which I'm going to talk shortly. First of all, this is the umbrella of features that Delta Lake provides: asset transaction, schema evolution, enforcement, unified batch and streaming, open source format, scalable metadata, and all those things. So let's dive into each of this. But as I talk about any feature, I will also talk about challenge, so you understand better like why that feature is helpful. So let's say you have a failed production job. And does this snapshot look familiar? This is like a cluster which failed in the middle, and you get this error message. Now you're complaining, where is my data? Where am I getting this error, right? So this happened after 2 hours of running your pipeline, and now your data is like sitting there corrupt. Once data goes through the flow, now your data engineering team has to make sure to point where the corrupt data was, where the corruption happened, how much data already made it through the pipeline, and how much insertion still requires. So to tackle that, we will see the solution later. But second reliability challenge is lack of consistency. In data world, we often need to do updates to the schema. We need to insert new records, and all these things can often create inconsistencies. They can often create like you cannot validate the data. So you need to make sure that if there are any updates that is happening, you have that kind of visibility for your data pipeline. So for example, to deal with this, if Delta didn't exist, in legacy data pipelines, engineer will have to figure out the new rows that need to be inserted. They need to know what rows need to be replaced out of corruption. They need to know what rows are not impacted so that they can preserve those rows and skip the new ones. They need to create a new temporary table with the records that need to be inserted, and then they need to delete the original table with corruption data, and then rename the table, drop the table. So there are a lot of things that they need to do. But in Delta Lake, since it adds that transaction layer, changes to every table is stored as atomic units. What atomic unit means is it's stored in its entirety. So anytime an error like that occur, it will just fail the operation completely. So you are not injecting any split data in your pipeline, any partial data to your pipeline. And each commit that I showed you under the JSON, under the Delta log directory, is a list of set of actions that were performed on that specific table. So that was about the atomicity, and then how does it offer consistent snapshots? So Delta has this property of multi-version concurrency control, and in multi-version concurrency control, it makes sure that anytime a reader is actually reading your table has a consistent file. If somebody is writing it, it prevents that from the readability. And it also offers ACID via mutual exclusion. So whenever concurrent writers are actually writing to the same table, they need to agree on the order of changes. For example, if you are in a Netflix competition and you miss by 2 seconds, the first winner will win and second winner will find the company like Databricks. And new files must be created mutually exclusively. So in this case, when 2 writers are writing on the same file, writer 2 will succeed and writer 1 will fail. They might make it in the next transaction, but they will not make it in the first transaction. And the file 002.json by writer 2 will succeed. And third challenge is schema enforcement. For example, I have this Parquet table with 14,000 records, and I'm running a stream query. After running my stream query, what should happen? This is what happens in Parquet. It goes through, my operation is successful, but my records are 51. And also, I see 2 new columns added. Where did 2 columns come from? Where are my previous original records? If this happens in Parquet, how will you be able to go back to your previous version? So this should not happen. Parquet should have just failed this operation. This is why schema handling is something that Delta offers to deal with that corruption issue. So here, when you run that same operation, it will fail. Delta will give you warning that schema was mismatched. And once you get the warning, now you're alert. Now you can fix your pipeline. So you do the schema enforcement. How you do schema enforcement is by using .option merge. So Delta allows you to merge the schema. So you preserve your original files and then also add the new schema as well as keep all the records from both old table and new table. Data skipping, it allows you to capture min and max values of columns. So for example, if you have petabytes of data, the statistics are really helpful to skip scanning the files, and it's really helpful for performance optimization. So here, when I'm running this query, this will skip the file1.parquet and file2.parquet, because my record, my user ID 24,000 is not to be found in first 2, but only in the third one. We have generated columns. So for example, if you want to evolve your date, you don't have to write a specific operation. You can just use generated columns command, and Delta will figure the operation out behind the scenes. Z-ordering we just released. It allows you to optimize further by from two-dimensional curve to three-dimensional curve, so you can actually sort your data better. And this, along with the data skipping, works very well for performance optimization. And then, as I showed you, the transaction log, that can be useful for a variety of different use cases because it allows you to capture historical data. So you can do that for auditing. You can retrieve the go back to the previous version and retrieve that data back as a current file. So it allows you in terms of failures as well. I want to quickly show the innovation that has been happening in Delta. So this is how far we have come along. We just celebrated Delta's 3rd birthday yesterday. This was the summit 3 years ago where we announced it. And these are the so many features we have released so far. And Michael released this on Tuesday, 2.0, with all the cool features that will allow you to take the optimization to the next level. And we are also, since we are open, we are working with other ecosystem communities to bring those integrations to the table. So if you want to, and this is the benchmark where it shows how these features have helped us to perform better. If you want to contribute, head over to our GitHub. You can do the discussions there. So let me go quickly over the community. This is the adoption of Delta Lake. This is how we have come along. 1 exabyte of data per day gets processed on Delta. We have 6,000 plus Slack members and 50 plus companies contributing. And these are the number of downloads. You can engage with us through various channels: Slack, GitHub, Delta, YouTube, LinkedIn. And you can contribute to the project. We have contributing guidelines. So head over to our GitHub. This is the link. You will find the good first issue, participate in a discussion, or you can create a pull request if you have a good idea. And then we also do office hours every 2 weeks. If you want to ask questions or ask questions about how to contribute, we will welcome all of that. This presentation was just one of them. We had 17 plus different Delta presentations throughout the summit, and Ask Me Anything panels. So feel free to check that out. It will be available on the virtual platform. With that, thank you so much. Sorry.
Thanks, Vinny.